Good afternoon, everyone, and welcome once again to the ECA Technical Tuesdays webinar series. Our Technical Tuesdays sessions are delivered by our expert technical team exclusively for ECA members. Today, we are joined by our technical manager, Chris Edwards. Today, Chris is going to tell you all about emergency lighting and handover documentation. But just before I hand over to Chris to kick us off, you should have a question mark button at the bottom right-hand side of your screen. Please do feel free to use that at any time in today's session to ask your questions, and we will try to answer as many as we can at the end. The session will be recorded and available, but only for ECA members, so you will need to log in using your login details on the ECA website to access the replay. For all sorts of other technical videos, also covering other topics that aren't technical, legal and business, education skills, employee relations, do have a look at the ECA YouTube channel. That's at youtube.com/ECA live, with lots more material there, as well as on the ECA website itself. So that's enough from me. Now over to you, Chris.
Good afternoon, everybody. Thank you, Omar. This afternoon, as you can see on the screen there, what I hope to do is discuss or talk about emergency lighting, and specifically these points. We're going to be looking at legislation and standards. We're going to be looking at the purpose and the types of emergency lighting. I'm going to touch on design. We will be going over a few items with design, but of course design is huge, so I can't cover everything in this presentation here. But we will be looking at things like illumination, duration and operation of power supplies, etc. And then, of course, at the end, we shall also be looking at testing requirements and certification and what that looks like. Okay, so what is emergency lighting? Well, I'm sure you've all heard of emergency lighting, and hopefully we all know that it's there in the event of a power failure, that the building and the safety equipment is still illuminated to a suitable level to allow for activities to continue, or for evacuation, more importantly, to take place safely. Emergency lighting will also facilitate safe exit from the building. It allows potentially dangerous equipment to be made safe before evacuation. And an integral part of this would also be that it enables emergency services to search and locate missing people. So in other words, it provides lighting in the premises for a duration of time, whereby we can either get out or people can be searched for, or you can find what you're looking for, etc. So there are, as you can imagine, a number of standards and legislation that apply to emergency lighting. The main one that I'm going to be referring to today, of course, is the British Standard 5266. And within that document, it tells us this. It tells us that UK legislation does indeed impose a duty on persons, including employers and other persons with control of the premises, of course. Now, their duty is to carry out risk assessment and to take such precautions as to ensure, as far as is reasonably practicable, the safety of the occupants. And an integral part, of course, of that would be that they need to consider or make allowance for the provision of safe means of escape, including emergency escape routes and exits, together with, when necessary, signs indicating them. So that's the pointer in the British Standard. This is a code of practice. But there is legislation. And the first one that I'm going to refer to is the Regulatory Reform Order 2005 in England and Wales, and is the legislation that ensures that fire safety is designated as a key role of responsibility for responsible persons. As part of that, it requires an assessment to be undertaken at the premises by a suitably skilled person to determine the precautions. Now, I've highlighted suitably skilled there for a reason. Before we move on too much, this is becoming more and more high profile specifically in the electrical industry, but within all industries, within the build industry, certainly. There is a requirement for competence, and it's been that case, particularly in the electrical industry, for quite a while. It's the Electricity at Work regulations, of course, Regulation 16, which refers to competence. But the reason I've highlighted it there, again, as I've just mentioned, is becoming much more high profile. The Building Safety Act has started to make changes within our build environment, and they have brand new regulations as a part of that whole suite of documentation with regard to the Building Safety Act that specifically encompasses competence. Finally, as I'm sure most of you are aware, the Grenfell Phase 2 report was out just last month, and there's a huge sweeping number of recommendations in that, one of which is that there should be a competency framework for fire risk assessors. So it's coming, it's been there for a while, but it's just, we're starting to get more detail in this sort of legislation. But anyway, this is the regulatory reform fire safety order. And within that, it's specifically clause 14 that requires emergency routes and exits to be identified by signs, and they require illumination. So that is legislation. We also have approved document B, which is specifically relating to fire safety, and underneath there at the bottom of the slide, you can see that it covers emergency lighting, and it tells us that escape routes ought to be adequately lit and signs provided, and escape lighting should conform to BS 5266. And that's quite a nice little link actually, because 5266 is directly referred to, you could consider this to be a building regulation, and therefore has a direct link to current legislation. Whilst 5266 is not statutory documentation, it's nice to see that link, and it would be very difficult to argue why you didn't comply with it because of these sort of references. So this is the framework. We know that the legislation is in law, that tells us what we need to do, but sometimes we need the detail, and this is where we need the documents under here in this 5266, which I'm going to be referring to today. Right, moving on to the functions of emergency lighting. There are a number of functions that we need emergency lighting to perform in the event of a power failure, of course. And the first one we're going to look at is if we have considered that, or we wish to evacuate the building immediately. And in that sort of situation, the emergency lighting that we're referring to would be emergency escape lighting, and this is where in the blue box underneath we would need immediate total evacuation of the premises. But that's not always the case. We may decide in certain situations that we wish to stay put in the building. We don't need to evacuate immediately, in which case that type of system is referred to emergency safety lighting, i.e. we're safe to stay in the building for a perceived amount of time before we need to get out. We don't need to evacuate immediately. And the other option is this, continue as normal. That's referred to as standby lighting. It just means that something else kicks in, normal lighting is resumed effectively, and we can just carry on as normal. So they are some of the functions of emergency lighting, and the system will depend upon the risk assessment. But with regard to emergency lighting, it's not just the escape routes. Emergency lighting or emergency escape lighting consists of a few different parts. Obviously, there is the escape route, the main concourse, as it were, from A to B that tells us that leads us to a point of safety. But we may well be in other areas too, and those other areas are defined as open area lighting or general congregation area for staff. It could be a canteen, for instance, or high risk area lighting. Typically, this would be in industrial around machines, but not necessarily only that type of scenario. But you have different implications for these different areas, which we'll look at shortly. The objective, of course, of the escape routes or the escape route lighting is to enable safe exit for occupants by providing appropriate visual conditions and direction finding on escape routes to ensure that firefighting and safety equipment can be readily located and used. And of course, you can also find your way out. So in other words, it gives us a degree of light when in an emergency. We can get to where we need to go. It's as simple as that, really, without stumbling into each other. And we can find equipment that we may need to find, firefighting, first aid room, that sort of thing. Open area, that part of an emergency escape lighting provided to avoid panic and provide illumination, allowing people to reach the escape route, sometimes called anti-panic lighting. You notice on the bottom here, where you can find further detail of these points. High risk areas, that part of the emergency escape lighting that provides illumination for the safety of people involved in a potentially dangerous process or situation and to enable proper shutdown procedures. That's really important, isn't it? So if they're using a bit of equipment, rotating wheel or whatever it may be, if the power's cut at that point, you want sufficient illumination when they're not going to be endanger themselves or indeed other people. And that's what it's all about. And the detail can be found in 5266 at the bottom there. So what about safety lighting? Well, this is where we're going to stay put for a while. If the lighting in a premises or part of a premises fails, it may not be automatic. It may not automatically be an emergency where evacuation is necessary. Depending on the risk and the building occupants, they may be allowed to stay put up to a certain point. And this, of course, is where the risk assessment comes into play. And we'll be looking at that a little bit later on. There are many, many factors to consider. But of course, if you have this type of lighting, we will also need to consider escape routes and safety signs are still illuminated and identifiable. But we might not necessarily have to rush out of the building. We may have more of a relaxed approach to getting people out, more time on our hands effectively. And the final one is considered to be standby lighting, continue as normal, that part of the emergency lighting provided to enable normal activities just to continue. And again, similar situation, must comply with the requirements of emergency escape lighting. It probably will do, given that its normal lighting conditions are going to apply. And as we'll see later on, escape lightings or illuminance of escape lightings is actually quite low. A normal day-to-day lighting of the premises will probably be higher than that. But anyway, we do need to consider it to make sure it's adequate in these situations. So they are the different types of functions or lighting, or functions of emergency lighting. Which system is best? It depends. You can't say one system is better than another because it depends on the building, it depends on the use, it depends on the occupants, the size, whether you've got a sleeping accommodation, all that sort of things. And again, it comes back to the risk assessment and the decision-making process, which we're going to look at in a minute. So, design and consultation. As you can imagine, 5266 gives us a lot of information about design and the processes that we need to consider when we're putting together, when we're thinking about designing an emergency lighting system. And the point is that it's a strong recommendation that at a very early stage, we get everybody, every placeholder, everybody who's going to be likely to have an input into this design involved at the start, so that it looks something like this. So you're going to have the building owner, of course, potentially an architect, the occupier, the lighting designer, installer, building control specifically too. That's a really good point. But the building controller who's likely to be signing it off. If you've got any queries about the requirements, it's best to get them involved at an early date. Now, I do appreciate that this is an ideal world, and this will vary depending on the size of the building, the use of the building, etc. But the point is that we need to communicate. We need to get as many people in place at the start so that they have input into this system. And it's a crucial aspect that we communicate and we get everybody involved wherever possible. Because there are many, many items to consider during the consultation process. Now, we've mentioned risk assessment, and that would ultimately be the starting point. So when we're doing the risk assessment, we need to look at the layout of the premises. We need to consider what are the risks, how the risks are mitigated, and that may tell us, hopefully, what sort of system is going to be best for us, whether we're just going to have escape lighting, whether we're going to have standby lighting, safety lighting, sorry, or whether we're going to have standby lighting, either one of which has its own implications, particularly well, as you can see there, we're going to need policies and procedures regardless. But with regard to safety lighting, how long are we going to keep people in the premises for? How long have we got? Period of time that we're likely to need before we get people out. Escape or standby lighting, I mentioned is escape lighting also required, and if we are going to be using that type of lighting, we may have generator installation types to consider too. We potentially will do with safety lighting, depending on what sort of alternative power we are using. But do you see what I mean? It can be really complex. It's not necessarily straightforward. If you've got a small building, yes, it's likely to be relatively straightforward. But the bigger the building, the more complex its usage. All these other considerations need to be taken into account so that we've got the right system in place at the time. You know, obviously part of this will involve the basic factors. We need to plot our escape routes, plot our escape signs, and plot our locations for infill lighting. And what I mean by that, we'll look at in a second. And what sort of personnel we are likely to have on the premises at the time, all the time potentially, some of the time, because that sort of information is important, because that may well lead us to whether we are going to be having a manual test facility or an automatic test facility. And the commissioning considerations are also important. Who are we going to be getting to do our commissioning? What sort of information do we need to be provided at that commissioning stage? All this sort of stuff is important to consider right at the start. So we've got the answers to these questions in place. And I've tried to highlight just some pertinent points. I mean, it is, as you can see, the bigger the building, the bigger the use, etc., can be very, very complex. But this is the reason that we need all the placeholders in place, if possible, right at the start, so they can have some valid input. So we get this right. It's important. It's a legal requirement. And of course, consultation, therefore, is key. And there are many factors to consider. But if we are therefore going to be designing our system, our emergency lighting system, we may wish to consider step one, the detail or detail the points of emphasis. So you would predominantly use a floor plan for this. Now, this is not the only way of doing it, of course, but this may be a common way of providing the information and building up the information. So you start off with a floor map of your premises, and we would look at the detail, the points of emphasis on our plan, as it were. So what I'm talking about are things like this. We would need to emphasize, or we would need emphasis on an exit door, for instance. We would need to ensure that the outside, the final exits, is also illuminated so people can walk to or travel to a place of safety. And that all exit signs, if they're not illuminated themselves, would need illumination. We also need to consider stairs, obviously. That would be a hazard, any change of direction, or any first aid points or firefighting equipment that we may wish to highlight as part of this may be important. Any other change of floor level, not just stairs, any change of direction, any intersection of corridors, and we've already mentioned firefighting or first aid equipment. So our points of emphasis, we would need to detail on our plan. So once we've got that established, we might then consider the signs. When I say signs, well, there's a whole suite of signs that we can use, all detailed, as you can see here, 5.2.9.1.1 tells us the detail, it gives us the detail, and it points us to another British standard, this time 5499, that outlines, as you can see in the diagram here, all the different options that we may use. Can be illuminated or not, of course. And then once we've established our points of emphasis and we've established what signs we're going to use, we would consider infill lighting. Now, I've ripped this figure directly from the example in 522 just to emphasize the point that we're getting at. So this may be a typical installation with the different rooms there labeled A to E or to G. And it gives us guidance with regard to whether we need to provide lighting or not. Now, of course, we know in the escape room lighting, escape route, of course, we are going to need to provide emergency lighting. And it tells us there at the right-hand column. But what about for room A? Well, room A is a small office, but it becomes the escape route of the inner room and therefore needs lighting. So if somebody were in inner room B, they would need to travel through A in order to get to the escape route. And for that reason, we would need to consider infill lighting within room A. Room B, no, funnily enough, you wouldn't actually need emergency lighting within that room because as soon as you open the door to it, it's only a small room. As soon as you open the door to it, you would have illumination provided within A, sufficient so that you can get into the escape route corridor. Would you need it in C? Yes, there's special requirements in kitchens, and you would require it in C. Would you require it in D? Yes, because the escape route passes through this to an exit outside. Would you need it in D? Yes, because of the area. That is considered open area lighting, of course. Would you need it in F? Potentially not. It's less than 60 meters. General guidance is potentially not, but your risk assessment may tell you otherwise. So this gives us an important caveat now. So general guidance, no, because it's under 60 meters square. Not generally, but your risk assessment, of course, can override that if you deem it a requirement. And this, of course, comes back to the point we made right at the beginning. We need a competent person to do this. We need somebody who is skilled, has the knowledge to understand the implications here. It's not something that you can just think, well, I'll take a stab at it. It's not like that. It has much more serious implications. And room G, lastly, would you need it in there? Yes, because of the size in that situation, because it's over 8 meters square. As I say, I've written this directly from BS 5266. The full details can be found within that document. Now, when it comes to illumination, 5266 does indeed stipulate specific lux levels must be required in certain situations, depending on the location, the use of the room, and the type of the emergency lighting. The point is, though, over illumination is fine, under illumination obviously is not. Now, in the standard, it gives us some really basic illumination targets to hit within certain areas, which I'll have a look at in a second. And I just wish to reiterate at this point, it is the bare minimum that we ought to consider. It's better to overachieve those for all sorts of reasons, not least of which is if this is likely to be installed for some considerable time. Don't forget, things do degrade over time, and if we're just achieving, say for instance, 1 lux at the beginning when everything's brand new and the lamps are brand new, when the batteries are brand new, we may not be achieving that in a couple of years, and we need to be on the lookout for that. So it depends on the system we've chosen. For emergency escape lighting and the escape route specifically, we need to provide 1 lux at the center line as a minimum in the escape route up to 2 meters wide. Now, there are other implications for different sizes, but obviously I'm just trying to highlight some bullet points here. The full detail is available in 5266, of course. Open areas, generally over 60 square meters, we only need to provide half a lux and excludes the border around the room generally. But for high risk, as you can imagine, it's a higher risk, an elevated risk, so we need more lighting. And the minimum is 15 lux or 10% of the average of normal lighting. But again, this just highlights the point. This can now start to get quite complicated. We need somebody who's competent to understand these areas, understand the requirements. regard to safety lighting, now this is the stay put for a while, isn't it? The minimum illuminance over the area where people might have to move during a failure of the supply to the normal lighting should not be less than 1 lux. But again, your risk assessment may determine if this needs to be higher. For instance, to facilitate safe movement of visually impaired people, as an example. Not the only example, but I keep on coming back to the importance of the competent person. We need to consider all these risks because 1 lux might not be sufficient if you're building houses visually impaired people on a regular basis, of course. Standby lighting, not so much of a concern because, of course, the function of standby lighting is just to replace the normal lighting. So by default, if the normal lighting is deemed adequate, then so with the standby lighting. But I did mention at the start, we do need to also consider the exit routes, but by default, they should be okay. But the idea of standby lighting, of course, is that they can just go about their day-to-day functions normally. Now, also, as part of the design, we may wish to consider how long we require the emergency lighting to function for. There are 2 options. We can either have the emergency lighting to be guaranteed to operate for an hour or 3 hours. Now, the 1 hour is the basic requirement, and of course that would be for immediate evacuation. We've got an hour to get out. We know we can get out safely in an hour, or hopefully under an hour, so therefore we need it only for an hour. But if you're likely to take longer than that, or for any other reason, then we may wish to consider 3 hours. But the options are both there, and it's clause 6.7.3 in 5266 that you may wish to consider if you're pondering which one to use. It will depend, of course, on the size and the complexity of the building. The duration is dependent not only on the time to evacuate the premises, but also on whether they are evacuated immediately, or whether they will be reoccupied immediately, that the supply is restored, and that's a really key function. If you are only using the 60 minutes, don't forget 60 minutes is considered to be the bare minimum. So in order to use the premises again, we need to ensure that we've got 60 minutes back in the system. So if you are going to be using a 60-minute duration emergency lighting system, that's not something that we can do. We need to stay outside until the batteries are fully recharged, and then we're allowed to go back in. Or the 3-hour one where evacuation is not immediate, or evacuation may take a little bit longer. There are loads and loads of examples here, all in that section there, but particular examples would be for the 3-hour location, places of entertainment or sleeping accommodation. Or if you wish to reoccupy before the batteries are fully recharged and have a minimum of 1 hour in them, of course. So they are your options, and maybe some of the considerations that we need to make when deciding on which one to use. Now, that has implications, of course, on the power supplies and the equipment. And what I'm talking about here, if we are going to be using self-contained light fittings, other considerations when we are considering our design that we need to think about are these when we're using self-contained light fittings. Generally cheaper, which we look at in a second, because by and large, these are the day-to-day lights that we're using, and we don't need to consider any additional cabling required. But if we're going to be using larger and more complex systems, and therefore we're going to enroll a central power supply, normally battery, these can be more expensive because there are other implications that now we need to consider. Notwithstanding, electrical circuit linking emergency lights is required to be fire resistant. So that may be a well, certainly would be an important consideration, particularly with expense. But what about generators? If we're going to be installing generators, well, generators, it states, need to be located in a low fire risk area. We need to consider the testing and maintenance procedures for them. And generally speaking, they're the same. Fire resistant insulation, cabling, addition and cabling would be required for these, but there are all different items to consider. It could be really, really complex. And we haven't even touched on as well the parallel systems that you can have that will facilitate testing. But we'll come to that a little bit later on. So which are best? Well, again, it does depend on your requirements, the use, the function, and potentially the budget. For instance, if you have a self-contained fit-in with internal batteries, for instance, these are generally faster and cheaper to install, and we can use our standard cabling. No additional cabling needed, no fire-resistant cabling needed. But we may need to consider the batteries require periodic replacement, and generally speaking, they don't have the same sort of output capability of larger systems. Now, depending on what system they are used for, of course, if you're only trying to aim for 1 lux, that may not be a problem. But if we're aiming for larger lux outputs, it may be a problem. So these are the sort of things that we need to consider. Central battery systems, generally considered to be more robust for many, many reasons. I've only highlighted a couple here. The battery life can be up to 15 years as opposed to 4 or 5 years for the self-contained. We can use existing luminaires, so they would be pros. Generally speaking, they are more reliable, more robust in regard to temperature fluctuations, that sort of thing. But for central battery systems, it can be more onerous for the testing. It is a requirement that daily checks are required. They're certainly more expensive to install, and we also need to think about the rooms for our batteries. Now we need to have a dedicated room. We need to consider ventilation, potentially automatic systems to test them, etc., etc. And generators, generally speaking, they can accommodate much larger loads and potentially have a longer runtime than batteries. It depends on the fuel, of course. But of course, again, they are more costly to install and to maintain. So there are so many considerations. But again, it just does depend on how big your building is, your requirements, etc., etc. Now, we've touched on testing. So let's have a look at this. Electrical testing is easy. We all know about that. It's as per the requirements of BS 7671, of course. And let's not forget approved document P. If you're operating in those environments where approved document P is applicable, then if you're going to be installing new circuits, that is considered to be notifiable work. But we know that. But what about emergency lighting on its own? Well, periodic testing, all relevant testing should be undertaken by a competent person. But this doesn't necessarily mean that they have to be a skilled person. For some, we could use an instructed person. Now, the sort of thing that I'm referring to here, if you've got a central battery system and they are instructed, you could get them to walk around to do visual inspections. When I say visual, you're looking for signs of damage, you're looking for the little LED indicator is operating, that sort of thing. Very basic, and you don't necessarily need to be a skilled person for that. But that is a requirement if you have a central battery that you perform daily tests. That's a daily manual test. Of course, you may have an automatic system where you don't need to worry about somebody walking around. Monthly tests are a requirement, short duration tests to ensure that luminaires work correctly. All this detail, of course, can be found in section 12 of BS 5266. But it is a recommendation that monthly tests are performed and a partial test is performed, short duration test to ensure that luminaires work. And then, of course, an annual test, fuel duration shutdown to ensure that the luminaires meet the 3-hour duration, if of course that's your system design. Now, the annual tests likely to be a competent person, as you can see at the bottom. The monthly tests could be an instructed person, but again, it's up to you. It depends on who you've got. Depends on the testing facility, if it's a manual test facility or whether it's an automatic test facility. But there are the recommendations once we've installed our system, that we perform periodic testing. This is a note, of course, in 5266, which I thought I'd highlight. The testing may be performed manually, but if the responsible person is unable to ensure that this will be done, it is advisable to use an automatic test system to perform the test at the required intervals. Of course, these intervals are the recommended intervals, and the recommendation therefore would be, look, you don't have to do it manually, but if you haven't got the right staff on place or in place at the time to be able to do that, then you may wish to consider automatic testing facility. So coming back to this certification and paperwork, what have we got to do when we're installing it? Well, first of all, once we put it in, there is a huge amount of paperwork and handover documentation that we are required to provide as part of that handover. And it's section 10.7 of 5266 that refers to this, and it tells us that there is a clear responsibility on the competent person to ensure that the documentation is delivered to the building responsible person during the handover. So it's literally the handover from the competent person, either one who's installed it, to the responsible person who has responsibility for the building. There is a requirement to hand over the detail. Now, this is a bit wordy, and apologies for that, but I had to include all of it because it's got some really good stuff, and the terminology I've referred to here. We're more used to our brown book and the requirements and the language in there. The brown book tells us that normally we're used to a shall requirement in that, and we know what a shall requirement is in the brown book. It's something that we ought to do. Well, in this code of practice, the language should carries the same sort of weight, so it's a similar sort of recommendation. So the competent person handed over the system to the responsible person should train the person or persons on the regular monthly tests and inspections and how to use the test facilities. The system documentation, including design, installation and verification declarations, certification, logbook, which we'll come on to in a sec, and any other relevant information should be handed over. So it's not a case of, right, there it is, here I'm off. There is a responsibility to hand this information over, and it's got to be, it's substantial information in that documentation. In particular, the importance of keeping the documents up to date by completing a logbook regularly and storing the documents in a safe place for reference as necessary should be explained. And the contact details of the competent person or the organisation should be given to the responsible person. So our contact details for any queries should also be included in the logbook, section 10.7, as you can see there on the right. So we have, luckily, this can be quite complex. Now, we have got a guide for ECA members. It's on the website at the moment. It's entitled A Guide to Emergency Lighting Handover Requirements. And within it, we tried to give you a few helpful steers, and I hope it is. I hope it's useful. And as you can see there, I've just highlighted one of the items in there, emergency lighting handover check sheet, because you know, sometimes it's difficult, isn't it? There's a bit of information here and a bit over here and a bit over here, and it's like, oh man, what have I got to do? Well, we've provided a handover checklist with reference. The text is a little bit small there, but with reference to 5266 and another standard as well, which gives us some detail of all the things that we should provide as part of the handover. But it's free to ECA members. Now, the logbook is quite a big one, because the logbook is required to contain a lot of detail, a lot of instruction, such as this. Is required to document the history of inspection, testing and maintenance. And it is clearly referred to in 5266 in this way. On completion of the work, of installation or part thereof, or of a major alteration to an existing installation. So it pretty much covers everything here. A commissioning test should be performed to check that the system meets the design requirements, and a completion certificate and logbook should be supplied to the owner. So it's covered everything here, and it's telling us the type of information that we should provide. Now, again, within that guidance document that I referred to a second ago, there is information about what should be provided within the logbook. And you might be surprised what is required to be in there. There's lots of information. Now, some of this will be more onerous than others because, of course, it comes back to how big the system is, the detail of the system. But these are the sort of things that we need to consider when we're entering detail. And I won't obviously cover all those. There's 12 parts there. The information is listed in our guidance notes, but you may be surprised. Calculations, drawings, commissioning data, equipment details, etc., etc., all required to be in the logbook. But with regard to certification, thankfully and rather handily, there are lots of different types and examples of that given in the annex of 5266, and it covers most eventualities. We've got the completion cert for small installations, larger installations, and it gives us an example of an emergency lighting logbook and how to verify existing installations. And just a little reminder at the bottom there, emergency lighting suite of documents is available. We do have our own in editable certs on the ECA website. But just to cover the certification, there are 3 types that I just wish to touch on today. And these are completion certificates that we have verified once we've installed that it meets the design. We have installed it correctly and properly. And there are 2 certificates. In fact, they don't actually vary very much, but there are 2 anyway, for 26 lights plus, for 25 lights and under, or for existing site compliance certificate where we're trying to verify an existing system. We may well be asked to go and check a system to verify whether it is compliant or not, and that's the option that we will use there. Now, sadly, as you can imagine, when we are installing or when we are completing a completion certificate, the recommendation is that we don't just hand over the certificate or the completion documentation, but with that documentation, with the handover package, comes a whole host of other documents that we are required to provide. And I just want to highlight that now. Again, this is in the document that I've just referred to on the ECA website. So if we look at the top here, so this would be an emergency lighting completion certificate in grey there, and we need to issue that with the signed declaration of design, installation and verification, where that all comes as part of the design or the completion certificate. But it's the bottom bits that I wish to highlight here today, specifically the photometric design data, calculations, and spacing data and stuff. What are you talking about, Chris? Where's that information? Well, it can be found, and it is in 5266. So for photometric design data, general measuring illuminance detail can be found within Annex D. Detail for illuminance required in specific locations can be found in Annex E. There are quite a few of them. Kitchens, first aid rooms, for obvious reasons, would have a slightly heightened illuminance requirement than other general open areas, potentially, than other areas. So we may need to consider that. But there is detail within Annex D and Annex E. Guidance on illumination measurements and calculations can be found in Annex G. And it's just also worth mentioning this booklet here. This is CIBSE or SLL guide LG12. The only reason I mention that is because if you look on the completion certificate, it's mentioned in the small print at the bottom, as well as all these annexes. It says, look at that for some guidance. That may be helpful. Now, the easy option, of course, would be to ask the manufacturer to get involved. I know sometimes in the past where we were on bigger projects, we used to get the manufacturer, if we were buying, I don't know, 100 lights or whatever, we would say to them, come on, you can do the design for us, you can verify the design. And they'd be quite happy to do that, of course, because it may mean they sell another 20 lights. That's just an option. You may well be able to get the manufacturer to do this for you. And what about the spacing? Well, the original site design data will ideally contain the design spacing calculations, which can be checked against the installation. But it does say here, in practice, obtaining the data for existing installations can be difficult. So therefore, if authenticating spacing tables are not available, the nearest luminaire format with a similar battery voltage, capacity, and diffuser type can be used to estimate acceptability. It's a difficult one, isn't it? This is, if we're trying to verify an existing system, what are we supposed to go on? And it's trying to give us a bit of a lifeline here to say, look, use an alternative that's as close as you can get to it and use that data if need be. And this is, again, going back to use the manufacturer if you can. Authenticating spacing tables are produced by test houses and products checked for conformity, under that standard. So I'm just about online for time-wise. I hope that was relatively useful. As part of today, I'm going to leave that on the screen for a second. Please scan that QR code. There is a CPD certificate that when you scan that, it will just take you to a place where you've just asked to fill in a couple of details. There's no marketing aspect. It's just for putting your details on the certificate. That will then automate, an automated certificate will be delivered to your email address. But while I'm leaving that on the system, that's the end of the presentation today. Has anybody got any queries?
Thank you very much for that, Chris. Very in-depth, thorough presentation. Just to reiterate what Chris said about the professional development certificate. So at ECA, we have our own program of professional development certificates that are available upon attending Technical Tuesday webinar. These are available at the QR code on your screen now that Chris has very kindly shared. However, all attendees today will receive an automated email in about an hour's time or 1 hour after we shut down today's webinar, where you'll be able to access your certificate there as well. So don't worry if you're not quite able to scan the QR code here today. You'll receive an email with a link to your certificate in about an hour's time. So Chris, we have, I can count 3 at the moment, questions. Bear with us, everyone. Chris, I have sent those or tried to send those through to you on this webinar platform, but let me know if you can't see them, and I'm happy to just read them out.
Not as yet.
No worries at all. Let me just bring them up on my end, and we'll go through them the old school way, just the 2 of us, right? Here we go. So, first question here. This is their kind of scenario. That's looking for your advice. So, question says, in a WC larger than 8 square meters, does BS 5266 recommend emergency lighting in individual cubicles if emergency lighting is provided in the open area outside of the cubicles?
No, well, it depends on the layouts where you're going to be citing the emergency lighting in that area. There will be a consideration for people within the cubicles that can see what they're doing and they can get out, of course. So not necessarily. but potentially, I know that's a bit of a sit on the fence, but it does depend on a few issues. But if you've got any specific requirements, just email me, myself or Roma. I'll be happy to help you with those if need be. But it does depend on how big it is, and where you're placing the other emergency lighting in that area. And the design, I suppose, of the cubicle as well. I mean, you know, if the wall goes right up to the top, of course, and there would be no natural light into the cubicle, then yes. But if not, and the cubicle doesn't go up to the roof, etc., etc., you know, it's not necessarily as straightforward as you might think.
Thank you, Chris. I'm just popping your email address into the chat box there, just for further queries relating to today's presentation. As well as the email that you'll see in about now.
Sorry, Emma. I'm happy to share my own personal email. Absolutely no problem with that in the slightest. Can you also put the technical one on there, please, Omar, as well? Because should I not be here or available, it just means there's a resource there that is.
Yes, absolutely, no problem, Chris. That's done. So, question about the S5266-1. Are there plans for it to be updated as it is now 8 years old?
There certainly are. There are plans. I mean, we have been privy to some information. It looks like it is going to be updated next year. But from what I can see at the moment, the changes are only likely to be very minor. But yes, I think it was, you know what it's like. These things take ages, they drag on. It was supposed to be this year, but it is dragging on into next year. But yes, it is imminent. The final changes are yet to be confirmed. And when we are able to share that information with our members, we of course will do.
Thanks, Chris. Next question, is a lighting cert valid without an installation condition report number?
Sorry, say again?
Is a lighting cert valid without installation condition report number?
Is it valid without? I mean, it would be a twofold thing, wouldn't it? I mean, you would have an electrical installation certificate for the cabling, and then the design and verification of the emergency lighting per se is something different and something in addition to that. So the verification of the emergency lighting to 5266 is a separate thing from an EIC, which would verify the cabling as being confirmed. So depending what the task would be, if you are verifying a system, then you may not have the information, so it would be unknown if you're verifying an existing. But if you're working on an emergency lighting system, there you would presumably also have the information for the electrical certificate too. Is that what you meant?
So hopefully the person who asked that question will drop another comment in the questions box just to confirm that. Yeah, perhaps a bit of clarification needed there on that specific question, if you could please. But oh no, that's a separate question. We'll bear with us. I'll kind of have a look. I've got your email address, and we'll have a look after the presentation. We can get back to you with some more resources there, if that might be helpful. So moving on to.
I mean, I can't reiterate enough at this point that the technical team is here always for our members. We man the technical helpline Monday to Friday, 9 to 5. Don't hesitate to use our resources. It's part of your membership. You've got any queries about anything, give us a ring.
Absolutely. Next question here for you, Chris. Are there any specific considerations within systems, including both self-test and manual testing emergency luminaires?
Are there any considerations with regard to what?
Within systems, including both self-test and manual testing emergency luminaires?
I'm not sure I entirely understand the question, but obviously self-testing would normally involve a person, so they're going to be more time consuming. Then it might need to be a skilled person. Automatic systems would not necessarily, although you may wish to have somebody on site who understands if there's an alarm thrown up, of course. If you're asking whether you specifically have to have self-test or automated, no, you don't, but you do need to ensure that the routine tests are being performed as recommended. And indeed, by and large, if you're going to be installed in larger, more complex systems, by and large, the usual route is a self-test facility, but you don't necessarily have to, depending on your operation, the building layout, and the sort of competent staff available, skilled staff available. Does that answer your question? Is that what you meant?
I believe that should cover the question, but again, to the person who submitted that question, please do feel free to add clarification, and we can come back to you. Just a couple more here, Chris, before we log off for today. I see we're nearly up to 1 o'clock. So when completing battery replacements, what certificate would you recommend using?
Battery replacements. That's a good point. If you're replacing, well, I suppose it, you're back into. You're back into the options that we have seen, but almost you're potentially into maintenance, aren't you? There, it's almost, you could argue that it's a like for like replacement, and therefore, unless you are not altering the design parameters, you may well be better off with an internal sheet, like a maintenance form, just to say what you've done. You may wish to include, though, design information if, in other words, if you are changing the characteristics of that, you can confirm that you are meeting the requirements of the original design if need be, or indeed potentially you may be changing batteries if the design has changed. If the duration is longer. I mean, it depends on what, if it's a like-for-like maintenance, then I would suggest that you're not necessarily changing anything. You may wish to just confirm, and then maybe manufacturer's data would go with a maintenance. It's sort of akin to a 7671, isn't it? If you are just updating socket outlets or, replacing something that's worn out. But if you're changing design parameters, then I would suggest we're back to the model forms in 5266.
Thanks, Chris. We've got time for just one more quick question, but just before I read that out, there's a couple of questions today that might need a little bit more consideration, a little bit more thought, but I have the email addresses of the people who submitted those, so we can address those later on. And I would, for one last kind of plug for the members area of the ECA website, do log on to there using your membership number and login details, and check out our technical guidance notes and resources. Chris has mentioned today a couple that are relevant to this particular presentation, but you'll find all of our guidance notes there for a whole range of topics. So final question before we log off for the day. How do you get the true lux levels of the emergency lights? Through the manufacturer, or do you need to take a measurement yourself?
Oh, that is a really good question. Well, either or, I guess. I mean, design data would give you the information, but there is testing and how to test detail in 5266. I know that previously we used to do it the old-fashioned way, plot out grids and use verified and calibrated lux level meters. It's sort of an either or, really, as long as the design data and the manufacturer stands by their design data and gives you a statement along those lines, or you could verify it in the field by manual testing. It depends, doesn't it? It depends on how large the area is, the resources to do that. I mean, I'm referring to when I used to do it, we used to, it would be station platforms. And of course, that's a vast area and you have to grid them out, et cetera, et cetera. But if the area is a little bit smaller, that may not be too onerous and therefore might be recommended in a nice addition. But the first port of call would normally be that design data should be robust enough to be able to stand up to the Lux lights. You may wish to verify it by doing a bit of spot checking just to conform after installation, and then then you can go back to the designer if it's not compliant and say, well, but I wouldn't recommend doing more than spot checking initially to check the design if you're happy with it. But then, of course, if that manual testing then proves that the design isn't sufficient, then you may have a problem and wish to do a full suite of testing. But you would normally do one or the other. And it might be a client requirement too. We obviously had designers do our design, and we were also required to prove it. So hence we would do the verification on site too. But again, I'm afraid it does rely on so many factors. But again, please talk to us. We are here to help you. I can't reiterate enough. And it's not just about today. It's about us being there all the time for you.
Thank you, Chris. So we will wrap up there for today. We have overrun slightly. Apologies for that. Just before we close today's webinar, I will do a very short plug for the next ECA webinar. It will not be technical. The next ECA webinar is the very beginning of our brand new webinar series called ECA Business Fridays. Perhaps a working title at the moment, but these will be a series of webinars addressing the kind of business aspects when it comes to legal and commercial issues that ECA members may be having. These will be headed up by our Director of Legal and Business, Rob Driscoll, who many of you will be familiar with. And our first Business Fridays webinar will be focused on collateral warranties. Now, collateral warranties are a very common security document that many of you will have been asked to enter into on construction projects. So our Director of Legal and Business, Rob Driscoll, will be joined by our Legal and Commercial Advisor here at ECA, Obaid Ben Nasser, who will explain a bit more what a collateral warranty is, what pitfalls to look out for in your contracts, and how to negotiate to create fairer allocation of risk in your contracts. So there'll be promotional posts about that on our social media channels and in your regular ECA newsletters, so do keep an eye out for that, and make sure to sign up. That will be on the 11th of October at 9 a.m, bright and early. So thank you once again to everyone for joining us today, and thank you for the presentation, Chris. Excellent once again. And yeah, enjoy the rest of your afternoon.
Thank you, everybody.